Hello, let's explain a shallow copy and deep copy. But before we get into that, let's first discuss what are we copying exactly. We are copying data types in JavaScript. So let's review our data types. We have primitive and non-primitive data type, which we call them structural data type as well. The primitive data type here has a better, like it's Boolean, number, yeah, I mean integer, character, like can be a string, float, undefined. There are primitive type of data, and the non-primitives are the objects and functions, like objects, anything that can be made with new keyword or arrays, map, date. There are like non-primitive structural data type. When we want to copy them, we should be aware of our different data type of JavaScript first. Then I hope you also know that passing value is different than passing reference. Passing value, I told you there are different passing reference. So let's take a look at them. Here I'm gonna name my primitive data variable a to number 1, and then I'm gonna define another variable b, setting it equal to variable a. Then I'll be adding 1 to the b variable, and I'll be console logging variable b. What do you think our variable b will be? It will be number 2, right? Sorry, I should have put the positive on the other side. So it's gonna be, yeah, then it's gonna be number 2. So now what do you think it's a variable a? A is still number 1. Let's see it. Yes, our a is still number 1. Even though we added 1 to b, a didn't change its value. It seems like it had a different reference in memory for itself. And while we assigned b to a, JavaScript gave different stack in memory for variable b because they were primitive data type. So let's comment out this part, and let's talk about and give an example about passing reference and how does the copying is done in structural data type. Let's our a array be me. Let the b array be like you. Okay. No, sorry. I'll actually set the b array to a array as well. And then I'm gonna push one thing to b array. Like I'll push you to b array. And I'm gonna console log both of them. So before I run this code, I'll tell you what's the output. Since we are copying the structural data, when we push something to b array, it's gonna push it to a as well, because both of them are pointing to the same memory address in our RAM. You see? But what if I get rid of this? I push nothing. It's gonna they're gonna be the same. I gotta set it. Yeah. Okay, nice. So nice. Till here we understand the difference between passing value and passing references. Primitive data type, pass value; structured data type, pass reference. So now let's talk about another important concept of mutable and immutable. What are those? Let's say a name is Adler, and we wanna change the a name's first character to like H. I don't know. So we are actually asking it to replace the H by A by H. Do you think it's possible? So let's log our a name. We still get Adler. These are immutable. Primitive data types are immutable. You can't push anything to them. You can't change them. They are immutable. But how about if we say our array is me and you? Now I'm gonna just see if we can push anything to array. They are mutable, but primitives are immutable. We can push anything to the array. Day. I'm gonna push day there. Let's see. Let's console log our B array again. Actually, I can console log A array because they are pointing to the same thing, right? Here didn't work because I always forget to put parentheses inside of the curly braces. Okay, here. As we can see, they have day. I can even console log the B array. It's still the same thing. They are pointing on the same spot. So now that we learned about like muting and immutable, now I'm gonna also just mention another fact here. The const doesn't mean that you can mute or immute. As you know, we learned about const that the variable defined on that can be changed. That's right, they can't be reassigned again. Like if I say I have const of z array which copies from a array and pushes. Const can push, can change its data. They are mutable, but they can't be reassigned. I hope you got this point as well. Let's go to the, it's just primitive data types are unmutable or immutable, while structured data types are mutable. For the structured data type, we need deep copy, just to make things interesting. So deep copy is done by pure functions. But before we learn the pure functions, it's better we talk about the shallow copy and deep copy, which we are here for. These are the same things that we talked about. Okay, here our shallow copy starts. They both create clones of the data type. Both create a new reference, new stack in memory, and they pointed on the different pointer in the RAM. You see, it's a shallow copy, it's a new pointer, but it seems like there's a problem with shallow copy. But before I get into the problem, let's just discuss what's shallow copy. To fix our problem with the A array and B array, which were pointing in the same memory, we come up with the clones of the data, but there are different clones. The first one is the shallow copy. The sprayed operator in arrays gives us a shallow copy of its own. So how does it work? I'll come here and say I have a C array. I'm gonna name it const C array, and it takes the separator operator of the array and it even pushes number 10. Now it was named, so let's say even pushes she. Now if we console log our C array, what we will see? Let's see. Me, you, they, she. So what do you think we're gonna see about the B array if I console log B array as well? We only are gonna see what we had in the B array. That's interesting, because we just did shallow copy here. And to just illustrate that we are pointing in different stack of the memory, I'll say console log if the B array is strict equal to the C array, and it's gonna say no. While if we say, it's gonna say false, because they are pointing in different memory. But if we say B array and A array, which were just regular copy, it wasn't the separate operator, it's gonna say true because they are pointing in the same direction. Nice. The problem with shallow copy starts when we have nested arrays or objects. So what's that? You know what's that, but yeah. Okay, let's just review it one more time. Inside of the C array, we are going to push another array saying that it's he or him. Like here, one of them is he and one of them is him. So now let's console log C array. We have nested array, an array inside of an array. So now we are trying. So now let's push another thing inside of this nested array, he and him, and say we have a Z array, A, B, C, D should be. Is equal to C array. Spread operator, different memory. Console.log our D array. I'm pushing another he and him is a nested array inside of this array, and it's in position 0, 1, 2, 3, 4. So I will be pushing to the D array on its first position to the array's nested array. I'll be pushing the and now let's just console log it. Here we're gonna have our problems. I'm gonna get rid of these console logs to not just to mix it. Yes, we have oops on both of them. Didn't we just say that they, when we use this like spread operator that are pointing on different direction. Why we are adding something to the array, it still gets added to C array because they are nested. When we had nested array or nested objects, using the shallow copy by spread operator or slice or any other thing that we're gonna learn in the future, it doesn't go deep into the level of copy. So we gotta be using the deep copy when it comes into these situations.